Lesson 20, people, composite area. All right, so we've seen composite area, and a lot of times it means that we're breaking up this shape into smaller shapes so then we can add up the pieces to get that total area. Well, what we're seeing here more is what we refer to as shaded region. And the overall philosophy behind shaded region is find the big shape and then take away what you don't want. So let's take a look here. In this very first question, we've got ourselves a shaded region, and we've got circles. So what we want to see is we have the large circle, and then we're going to take away that smaller circle on the inside. By doing that, we'll be left with the shaded region. So getting the visual down here, the plan of attack, is always a good thing here. Formulas next, pi times radius squared. And when I'm looking at this large circle that's there, my radius turns out to be a 3. So, 3.14 for pi, so 3.14 times 3 squared. And again, we're going to take away that smaller one. So again, pi times radius squared. But my radius is now only a 2. So 3.14 times 2 squared. And then it's all about just reaching for the calculator and then typing it all in. Remember, you've got your exponent button that's there. So that's certainly something to make use out of. Minus 3.14 times 2 to the second power. And I forgot my decimal in there. So I'm going to go ahead. It is one of those things of where you do want to make sure that you are kind of, checking and making sure that you typed in. Because like I said, a lot of times you press and it doesn't work. 15.7. All right, so 15 and 7/10. And looks like we're just units squared because we don't know our units of measurement that's there. But that's the general theme that we're looking for. Let's see here. We got a yard. With a shaded section indicating grassy areas. Unshaded, paved areas. Okay, so find the area of the space covered with the grass that we are using. So, all right. Really what we're looking for here is with the grass. So even though I've got this large shape that's out there, that's not really something that I'm going to be using. I'm looking at finding the area of this and then subtracting out this particular portion that we're dealing with. Now, the only thing I don't like about this particular problem, and we kind of just get our visual down here, length times width, is that we really can't get an idea of halves or quarters. So, not a fair question. I believe they'd like us to make the assumption they're quarters here, but again, I never like you to get into that situation. So, we're going to skip that one. Again, technique is more of what we're after that's there. Okay. The whole thing is shaded. So, this just takes us back to what we saw from before, is that, okay, we've got ourselves our half circle with our rectangle we're using here. Now, we are going to do this one because this is a good one to see how the shapes mingle together. So we've got that semicircle plus that rectangle we're looking for. So we know we're going to do pi times radius squared divided by 2 because it's the half circle. And again, I like getting the formulas down first because it keeps me focused and I don't forget to divide by 2 because we've all been there before. Okay, so remember that the sides of shapes can share, and so we can use that information. So because this is a 4, I know that this line is also a 4 as well. So, okay, 3.14 for pi, so 3.14 times, what's my radius? Well, it's only going to be half the amount, so that'll be 2 squared, and we'll divide it all by 2. Now, the length and the width, this is what kind of gets a little bit more interesting that's here, because the 7.5 goes all the way up to the top. I only want it to here. So that's not 7.5, but what we do want to realize is I know this particular line. That is the radius that's there. So we did know the radius is 2 from it, so that tells me that from here to here is going to be a 2. So if I know the entire distance is 7.5, and I know this top portion is a 2, there's my missing distance of 5 5/10. Yeah. And then we're going to multiply that times the 4 that we've got there. So, yeah, remember, a lot of this is a puzzle. So they're not going to give it to you. You're going to have to use it. And again, we want to keep in mind of techniques about the radius and how it matches with the diameter and how that matches with a rectangle. So, yeah, we'll punch that all in. 3.14 times 2 squared. We'll divide that by 2. I don't like typing everything into my calculator at once when I got these pieces just because I feel like it's too much and I kind of make a mistake. So 5.5 times the 4. So a lot of times I will go ahead and chunk it a little bit that's there. Individual shapes wise. So yeah, so 28 and 28 hundredths? No, yeah. Wow. All right. 28 there. Anytime those kind of numbers pop up there, I just don't know what to do with it. Yeah. So, yeah, you just got to kind of double check them there. So yeah, I like it there. I like it. Meter squared we're looking at there. All right, quality problem we've got there, people. Oh, here we go. Find the area of the shaded region. Okay, well, the entire shape is shaded. So, but we do want to see, hey, it's a triangle, and it is that half circle that we're using there. Now, again, this is one of those problems where we're going to have to hunt for the information. For my triangle, we're going to use base times height divided by 2. So I can see my right angle symbol, so I do need to figure out that height. Now, again, they didn't tell it to me, but they did tell me, hey, that's a 4. So this is where we want to kind of convey things together. Ooh, it's a 4. What part of the circle is that? Well, that's the radius, okay? What part of the circle is this? Ooh, that's the diameter. So if I know that the radius is 4, that's going to make the diameter 8. Now I've got enough to use. Hey, 14 times 8 divided by 2. All right. Half circle, so pi times radius squared divided by 2. All right. And now I can plug some people in. Oh, 3.14 again. All right, we're being consistent here. Times radius. The radius was 4, so 4 squared, and we're going to have to divide it by 2. So yeah, and now, like I said, it's about just getting those calculations. So yeah, that 14 times 8, all right, divided by 2. Like I said, I like to piece things together. 56 plus, and then the 3.14 times the 4 squared, and I'm going to divide that by 2. Okay. I got U, and then we total it on up, that's there. So grand total, 81 and 12 hundredths, and this would be centimeters squared. So again, the theme here of the radius and the diameter that are sharing particular sides there. All right, so very last one here that we want to work on, and the idea here is, yes, this is one of those shaded regions where I can find the area, and then I can take away those particular triangles that we don't like that's there. So, okay, rectangle, length times width, 20 times 20. I got a 400 that's there. So that's taken care of. Our first triangle here. Okay, let's see here. You're 20. Okay, so I know that's base and height there. 8 is all the way from here to here. The entire distance is 20. Ooh, so that makes you a 12. So there we go, 20 times 12, and we'll divide it by 2. So, yeah, that'll give me 120. Okay. This top triangle, I see the 20, all right. So, again, base and height. So, again, that right angle symbol that's there. So, I know I'm going to use my 20 again. I know the entire line is a 20. I know from here to here is 6. Okay, so 14. All right, that's nice. Nothing too fancy going on here. So, that'll be 140. And then the last little guy, oh my goodness, it's right there. There's my right angle, the 8 and the 6. Perfect. So yeah, 8 times 6, 48, divided by 2, 24. And oh wow, there we go. Hey, that was fast. Again, a lot of this is just the organization of your information, as I type things in the calculator here. And again, staying organized is really what it comes down to, 116 centimeters squared. Triangles, base height and height divided by 2, base and height always meeting at the right angle that we're looking at. So, yeah, people, that's it. I got nothing else for you as we look at these particular problems. So I would say that's time to go.